Hello friends, today I want to discuss operating principle of three-phase induction motor. This lecture is the second lecture of three-phase induction motor series. In this lecture I have covered what is the induction motor. A three-phase induction motor is a type of electric motor that is widely used in industrial and commercial application due to its robustness, simplicity, efficiency and reliability. It operates on the principle of electromagnetic induction and is powered by three-phase alternating current supply. The basic principle of operation. The basic principle of operation of three-phase induction motor is based on Faraday's law of electromagnetic induction. This motor works on the principle of electromagnetic induction. What is known as the induction motor because its work on induction principle. Electromagnetic induction refers to the phenomenon in which the electromotive force induced across the electrical conductor when it is placed in a rotating magnetic field. The stator and rotor are two main parts of the motor. This stationary part is a stator and is the overlapping winding are carried out by it. While the rotor carried the main or field windings, the windings of the stator are eventually displaced from each other by 120 degrees. In induction motor, the supply is applied on a part of one part of the stator, so it is known as the single excited motors. This process of induction inducing the magnetic field on the part of the motor is known as the excitation. This is the circuit diagram to understand the what is working principle of the motor. This is called soft. This is a rotor part, that is rotating part of the motor, that is called the stationary part. This is a stationary part is known as the stator. When three-phase supply is given to the stators, according to the Faraday's law of electromagnetic induction, rotating magnetic field is developed. This magnetic field is linked with rotor windings and produce a torque, and this torque is equal to force into perpendicular distance, and that's responsible to turning movement of rotor. Where the three-phase supply is fed to the stator and the rotating magnetic field is induced on it, the below given figure. So the rotating magnetic field set up in the stator. Consider the direction of the induced rotating magnetic field is an anti-clockwise direction. The rotating magnetic field has moving polarities. The magnetic field polarities vary by taking into account both the positive and negative half cycle of the supply. The magnetic field rotating happens when it changes polarities. The conductor of the rotor are stationary. The rotating magnetic field of the stator is cut by a stationary conductor, and because of the electromagnetic induction in the rotor, EMF will induce. This EMF is called the rotating induced EMF and is happened due to electromagnetic induction. In this way, the electric motor, three-phase motor starts rotation. For the rotation, the motor is required to force. This force is known as the electromagnetic force, yeah, that is called F equal to BIL sine theta, where B is the induction flux density, I is the current, and L is the length of the conductors. So in the rotating movement of rotor is responsible for the torque, where torque is defined. Torque is the force into perpendicular distance. In this way, the rotor of the motor, of three-phase induction motor, starts rotating. This is some pics of rotors, stationary rotors, squirrel cage type rotors, and bond type of rotors. In this way, the operating principle of three-phase induction motor is completed. Thank you for watching.